Hello everyone, welcome back to my channel. I know it's been a while, but you know, work also. I've been very busy. Once again, my name is Dr. Bisaya Otokiti, and today I'll be taking us through another series of one of the Statistics Made Easy class, part 2 of Statistics Made Easy class. And today we'll be looking at index numbers. Please come along with me as I take us through the journey of index number. If you are joining me for the first time, I say big welcome to you. If you're already an existing subscriber, I also thumbs up to you. God bless you all. Okay, let's start with what index number is, or what index numbers are. Index number are, like I said earlier, they are one of the most commonly used statistical tools for the 21st century, and there's hardly any organization or places in life that they don't make use, or that they won't make use of index number. And what are index numbers? They are specialized average that are designed to measure the net change over a group of related variable over a period of time. Then we say, let's look at this example. We said in the index number of wholesale prices in the year 2019, the price is 125% compared to that of 2018. If we want to see the difference between the price of 2018 and 2019, we are going to say that there is a 25% increase in the price of 2018 compared to that of 2019. Then, but for a proper understanding of what index numbers are, we should also take note of this following point. One, index number are specialized average, like I said, and they are used to measure change over a period of time. Then also, like I said, it is used to measure change over a change in a group of related variables over a period of time. What I did in this following point is just to break the definition down. One, they are specialized average. Two, they are used to measure the net change in a group of related variable. Then also it takes effect over a period of time. You can't say we want to know the index number between January and February. It is over a consistent period of time, or over a long period of time. Then we'd also be looking at the uses of index numbers. What are the uses of index numbers? One, they reveal trend and tendencies over a period of time. If you have been able to study a particular data or pattern of events over a period of time, they can tell you the trend and the likely tendencies over that period of time. They are also helpful in framing suitable policies. Then also they are tools, they are statistical tools, like I said earlier, that are indispensable in the 21st century. Then what are the classification of index number? We have price, we have quantity, then we have value. There are others that are not specified here, and as we go on in the class, you'd understand what price, quantity, and value means. Then what are the problems in constructing index numbers? There are a lot of problems, but I've just listed 4 because my board is a bit small. Okay, so the first problem of constructing index number is, what is the logic, or what is the reason, what is the purpose, what is the idea or behind an index? Then also another problem that could be found in index number is the selection of the base year or the base period. Then another problem is the choice of appropriate weights, or the choice of weight. Then lastly, selection of the appropriate formula to use for each of the indexes as we move on. Then we also have methods of constructing index numbers. The first method is called unweighted indices, while the second one is called weighted indices. They are further divided into simple terms. The first one is called simple aggregative, and the second one is called simple average of relative. That is under unweighted indices. Then for the weighted indices, we have weighted aggregative and we have weighted average of relatives. The next slide will be showing us how we solve each of these methods of constructing index, starting from unweighted and looking at the simple aggregative, simple average of relative. Then we'll also look at weighted indices, the types of weighted indices we have. We'll look at weighted aggregative, then we'll look at weighted average of relative. Then we'll look at examples and illustrations that suit all these methods that are listed on the board. Okay, taking each of the methods of constructing index, we are starting with unweighted index number. And under unweighted index number, we have the first one is simple aggregative method, and this is the simplest form of using index number. And the formula says summation of p1 all over summation of p0 times 100 all over 1. What is p1 and what is p0? Summation means total of all the prices of the current year. P1 means total prices of the current year. Then while P0 means total prices of the base year or the past year, of the base year or the past year. Looking at a logical example, these are the commodities, these are the prices in 2017, and these are the prices in 2018. The norms is that once 2017 was earlier, before 2018, we assume that 2017 is the base year or the past year, because from these 2 years on the board, 2018 seems to be the most recent year. We are not talking about 2021, we are just looking at the examples from the board between 2017 and 2018, which is the most recent year is 2018. And because 2018 is the most recent year, we say that is the current price. That is the current price. Then the previous year, which is 2017, we call it the base year price or the past year price. Then the formula says summation of P1 all over summation of P0 times 100 all over 1. Like we said, it is the simplest. Adding all this together, this plus this plus this plus this plus this will give us 300. Then 70 plus 60 plus 90 plus 120 plus 20 will give us 360. Then putting it into the formula, we have 360 all over 300 times 100. Then the 0 here will cancel 0 here, 0 here will cancel 0 here. Then 3 divided by 360, that is 120. So our answer is 120. So because this is in percentage, the interpretation of this result is that there is a 20% increase above the base year price. There is a 20% increase in the price of commodities comparing 2017 and 2018. I take again for a better understanding that this answer means that in 2017, comparing the price of commodity in 2017 to 2018, there is a 20% increase over the price of 2017, and that is why we have 120. Looking at illustration 2 now, illustration 2 says calculate the index number using 1, 2010 as the base year, then 2, using 2015 as the base year, then 3, using 2010 to 2012 as the base year. These are the simple illustration on the board, and I take you us through quickly. Then if you look at the question says we have year price. Then the first year is 2010, the second 2011, the third 2012, the fourth 2013, 2015 and 2016, and the prices are 4, 5, 6, 7, 8 and 10. And the first question says 2010 as the base year. Don't forget that the base year is always beneath the current year would come up. So looking at these prices as the current year and the base year is 2010, the value of base year is 4. So we come to the first line and say, since 2010 is our base year, the first one will be 4 divided by 4, that is the base year, times 100, that is 100. Then the current price for the second one is 5 divided by 4, that is the base year, times 100, we have 125. Then 6 is the current price divided by 4, that is the base year, times 100, we have 150. Then 7 is the next current price divided by 4, the base year, times 100, that's 175. Then the next current price is 8 divided by 4, the base year, times 100 is 200. Then the last one is 10, that is the current year, divided by 4 times 100 is equals to 250. We repeat the same method we have used for 2010 as the base year, for 2017 as the base year. The value for 2015 rather, this is not 2017, this is 2015. The value for 2015 is 10. So our base year automatically becomes 10. So 4 divided by 10 times 100, that's 40. 5 the next year divided by 10 that is the base year, times 100, that's 50. Then 6 the next year divided by 10, that is the base year, times 10 is equals to 60. Then 7 divided by 10, that is the base year, times 100 is equals to 70. Then 8 divided by 10 times 100 is equals to 80. Then 10 divided by 10 times 100 is equal to 100. It does not stop there, because the last question says we are using 2010 to 2012 as the base year, and looking at the price for 2010, 2011, 2012. Since there are 3 years, and they said from 2010 to 2012, they didn't say 2010 and 2012, from 2010 to 2012. What we do is just we take the average of the 3 years. So we have 4 plus 5 plus 6, that's equals to 15 divided by 3, that's 5. And that is exactly what I've done on the board. 4 plus 5 plus 6, that's 15 divided by 3, we have 5. So 5 becomes our base year. So we take the prices one after the other again and over 5, then multiply by 100 to get our value. So we say 4 over 5 times 100 is 80, then 5 over 5 times 100 is 100, then 6 over 5 times 100 is 120, then 7 over 5 times 100 is 140. 8 over 5 times 100 is 160. Then the last one, which says 10 over 5 times 100 is equals to 200. We can see they are simple arithmetic. There are simple things, if we put our mind to it, that we can get as fast as possible. Just know your current year, then know the base year, multiply by 100, then we are good to go. I believe everybody is going to get A in this course this semester. So the next one we'll be looking at is the simple average of relative, and this can be worked out using any measures of the central value, maybe harmonic mean, arithmetic mean, geometric mean, median, or mode. But I've just streamlined this to using the arithmetic mean formula, and it's just simple, it's basic from what we are coming from where we are coming from. So it's P01 is equals to summation of P1, the current year, all over the base year times 100, then all over n, that is the number of items whose price relative are being averaged. Then this is a simple illustration that shows this formula on the board and how we can derive at our answer. The question says find the index by the average of relative. Then we have commodity 1, 2, 3, 4, 5. We have prices in 2019 and prices in 2020, 50, 40, 80, 110, then 120. Then for 2020, 70, 60, 90, 120, then 20. Then the formula says the current price all over the base year price. From the board, the current price, the most current year is 2020 and the previous year is 2019. So it will be 70 divided by 50 times 100, we have 140. The next one will be 60 divided by 40 times 100, we have 150. The next one will be 90 divided by 80 times 100, we have 112.5. Then the next one will be 120 divided by 110 times 100, we have 109.1. Then the next one will be 20 divided by 20 times 100, we have 100. Since we are looking for the summation of all, 140 plus 150 plus 112.5 plus 109.1 plus 100, we have 611.6. Then putting into the formula, P1 all over summation of P1 all over P0 times 100, that is the total of this, that is 611.6 divided by the number of commodities, 1, 2, 3, 4, 5 divided by 5. Our answer is 122.32. Okay, the next one is the weighted index numbers, and as we can see on the board, they are assigned equal importance to all. Equal importance is assigned to all the items included in the index. Then we'll be looking at the weighted aggregative index first, and there are many methods that we can use, but this I've listed about 6 the most important methods to me. There are some other methods that are not included in this that you can find out in textbooks, online, and like that, but to me these are the most 6 important methods to me. I'm going to mention the 6 and what their formula entails. The first one is called last per year method, and it is the base year quantity are taken from the weight, and the formula is summation of P1. P1 means the current price, the current year price. Then Q0 means the base year quantity. Q means quantity, and anywhere you see 0, it means the base year or the past year. Then all over summation P0, the base year price, multiply by the base year quantity, multiply by 100. It does not stop there. We move to Pache method, and Pache method is the current year quantities are taken as weight. Then we have summation of P1, the price of the current year, multiplied by Q1, the quantity of the current year, all over summation of P0, the price of the past year or the base year, then multiplied by the quantity of the current year, multiplied by 100. Then the next one, which is the third one, is Dobish and Bolli's method. And Dobish and Bolli's method is just simple. Dobish and Bolli's method has brought last paye and Pache together and dividing it by 2. So the formula for last paye and Pache are brought together, divided by 2, multiply by 100. Then the Fisher's ideal method. The Fisher-Ideal method has also brought the idea of last paye and Pache together, multiplying the 2, then finding the square root, multiplying the 2, then finding the square root. Then the fifth one is called Marshall-Edgeworth method, and is equals to summation of P1 Q0 plus summation of P1 Q0 all over summation of P0 Q0 plus summation of P0 Q1 times 100. Then the last one is called the Kelly's method, and Kelly's method is just as simple as it is on the board, where we have summation of the price of the current year all over quantity. They have not stated if the quantity is for the past year or the current year. Then all over summation of price of the base year multiplied by quantity times 100. We'll do an analysis or an illustration now to see if all these formulas gives us a correct answer or not. So join me as I take you through another illustration. Okay, this illustration now says construct the index number of the prices of the following using last paye, Pache, Bolli's and Fisher's. Don't forget that the formula for last paye is summation of P1 Q1 all over summation of P0 Q0 times 100, and every other formula, and Pache is summation of P1 Q1 all over summation of P0 Q1, and every other formula, the basis or the foundation of every other formula is last paye and Pache. Then looking at the formula, how do we get what we need to do? This is the question on the body. Commodity is 1, 2, 3, 4, and the price of 2018 is 3, 6, 5 and 3. Then the quantity of 2018 is 9, 11, 15 and 20. The price of 2019 is 5, 7, 6 and 3. Then the quantity of 2019 is 7, 6, 11 and 14. Looking at the formula on the board for last paye is a summation of P1 Q1 all over summation of P0 Q0. That will determine what values we are looking for. So the first value I'm looking for is P1 Q0 from the formula, and the next value is P0 Q0 from the formula. Looking at Pache's formula too, P1 Q1, P1 Q1, P0 Q1, P0 Q1. So that is the way I'll solve out my answer. Looking at this, I have P1 Q0. This is P1 and this is Q0. So 5 times 9, 45. 7 times 11, 77. 6 times 15, 90. 3 times 20, 60. Then P0 Q0. P0 Q0. 3 times 9, 27. 6 times 11, 66. 5 times 15, 75. 3 times 20, 60. Then the other one says P1 Q1. P1 Q1. 5 times 5, 35. 7 times 6, 42. 6 times 11, 66. 3 times 14, 42. Then the last one says P0 Q1. P0 Q1. 3 times 7, 21. 3 times 6, 36. Okay, 6 times 6, 36. 5 times 11, 55. 3 times 14, 42. And looking at the formula, the total for all, we have 276. 45 plus 77 plus 90 plus 60 is equals to 276. Then 27 plus 66 plus 75 plus 60 is equals to 228. Then 35 plus 42 plus 66 plus 42 is equals to 185. Then the last one, 21 plus 36 plus 55 plus 42 is equals to 154. Then trying to solve the formula now. I'm trying to solve the formula. Last part here says summation of P1 Q0 all over summation of P0 Q0 times 100. Looking at the board, P1 Q0, the total is 272. I've written 272 out. Then summation of P0 Q0. P0 Q0 is 228. So 272 divided by 228 multiplied by 100, we have 119.3. Then the second formula says P1 Q1, total of P1 Q1 is 185. Then P0 Q1, P0 Q1, P0 Q1 is 154. All over 154 times 100, we have 120. Then for Dobish and Bolis is the addition of the two methods. The addition of the two methods divided by 100. Even if we add this one and add this together, we add 119.3 plus 120 divided by 2, we'll still arrive at that answer of 119.7. I've tried to write out the values again. 272 all over 228 plus 185 all over 154 times 100 divided by 2. So we have 119.7. Then the last one says the Fisher's method. The Fisher's method is the square root of the two, bringing the two formulas together, then finding the square root. The first answer is 119.3. Sorry, 119.3 multiply by 120, finding the square root, we have 119.6. The next thing we'll be looking at is the test of adequacy of index number formula. And because we have so many formulas, the test of adequacy just helps us to pick the most appropriate index or formulas to use for each of the index number that questions we are going to solve. And starting with, these are the test of adequacy's formulas. We have the unit test, we have the time reversal test, we have the factor reversal test, and we have the circular test. The unit test satisfies majority of the formulas, so there's no need to be proving. There are some others that it does not satisfy, but majority of our formulas it satisfies. But the time reversal test and the factor reversal test are the most important tests, and that is what we are going to prove. Then also there's an important thing to know, that it is only the Fisher's ID method that satisfies both the time reversal test and the factor reversal test that I'm going to prove. There are other methods that I don't necessarily need to prove. There are other methods that satisfy these two tests that I'm not going to prove. It is only the Fisher's ID method that I'm going to prove. Then what then is the time reversal test? The time reversal test determines whether a given method will work in both ways, time forward and looking backward, taking the time backward. We want to see if the formula the test will work for both ways. Then the factor reversal test also holds that the product of the price index and the quantity should be equal to the corresponding value of the index. We'll be proving whether the Fisher's ID method satisfies the time reversal test and whether the Fisher's ID method satisfies the factor reversal test as stated earlier, using the test of adequacy, time reversal and factor reversal test. And we want to use the Fisher ID method. Like I said, there are other methods of formula that have satisfied both of these tests, but I'm only trying to figure out if Fisher's ID method satisfies the both tests, which is time reversal test and factor reversal test. Looking at time reversal test, the formula for Fisher's ID method is square root of P1 Q0 all over summation of P0 Q0 multiplied by summation of P1 Q1 all over summation of P0 Q1. Then, like we said, time, we want to see if it can go backward and forward. So what we do simply is, everywhere we have seen 1, change it to 0, and everywhere you have seen 0, change it to 1. If you look at the formula says P01. So where there is 0 now, we are changing it to 1, and when there is 1, we are changing it to 0. So it becomes P10 is equals to summation of P0. Anywhere you see 1, you change it to 0. So P0, Q0 will become Q1 here, all over. P0 will become P1 here, Q0 will become Q1 here, then P1 becomes Q1 here, P1, P0, Q1, Q0, P0, Q1, and Q1, Q0. Anywhere there is 1, you change it to 0, and anywhere there is 0, you change it to 1. So bringing the two formulas into the same under the square root, we have summation of P1 Q0 all over summation of P0 Q0 times summation of P1 Q1 all over summation of P0 Q1 multiplied by summation of P0 Q1 all over summation of P1 Q1 multiplied by summation of P0 Q0 all over summation of P1 Q0. We want to see if it's equal to 1. This and this, it's the same. Then P1 Q0 Q0 is the same. P1 Q1 Q1 P0 Q1. So square root of 1 is also equals to 1. So it means that the Fisher ID method satisfies the time reversal test. Then the same principle that we have used for the time reversal test is a little advanced when it comes to the factor reversal test. And the factor reversal test just says anywhere you see P, change it to Q, and anywhere you see Q, that is quantity, change it to price. The formula says summation of P1 Q0 all over summation of P0 Q0 multiplied by summation of P1 Q1 all over summation of P0 Q1. Then the next one says summation of Q1, since anywhere we see P, we are changing it to Q, so it becomes Q1 P0 all over summation of Q0 P0 into times summation of Q1 P1 all over summation of Q0 P1. Then we bring everything back into the square root. So summation of P1 Q0 all over summation of P0 Q0 multiplied by summation of P1 Q1 all over summation of P0 Q1 times summation of Q1 P0 all over summation of Q0 P1 multiplied by summation of Q1 P1 all over summation of Q0 P1. We want to see if it goes. This is P0 Q0. Do we have P0 Q0? Do we have P0 Q0 on the board? We have Q0 P1. This is Q0 P1. So this crosses this out. Then we have P. Do we have P1 P1? We have Q. We have P1 Q1. Or this is P1 Q1. This is Q1 P1. So this cuts this out. What do we have? We have P1 summation of P1 Q1 summation of P1 Q1 squared. Then we have summation of P0 Q0 summation of P0 Q0 squared. So bringing it into the square root, summation of P1 Q1 squared, then summation of P0 Q0 squared. Because this is already in square root, it cancels the two squares. It cancels these two square that we are having, and our answer is summation of P1 Q1 all over summation of P0 Q1. And that means that the Fisher ID's method satisfies the time reversal test. Thank you all for watching. I hope you enjoyed this index number. If you have any question, feel free to drop your comments in the comment section below. I'll be willing to attend to all the questions and also respond to all your questions. Thank you, and God bless you. Bye.